besides seeing a lot of stuff that dudes say, do you see things that state game agencies are doing or the way they're thinking about these issues and management? Do you see things where you're like, that just doesn't make any sense?
You're wanting me to like step on a landmine?
Yes.
Yeah.
Yes, I would like that.
This is the MeatEater podcast coming at you shirtless, severely bug-bitten, and in my case, underwearless.
We hunt the MeatEater podcast.
You can't predict anything.
Brought to you by First Light. When I'm hunting, I need gear that won't quit. First Light builds no compromise gear that keeps me in the field longer. No shortcuts, just gear that works. Check it out at firstlight.com. That's FIRSTLITE.com. Kevin Monteith is here today. Second podcast appearance. Well, you're one of the top favorite guests we've ever had.
Are you just saying that to be nice?
No, I'm telling you, people love that show, dude. That was a big show. Over the years, we've had some big shows that people really liked and just generated a lot of stuff. That was a big show. That was episode 162, and it was called Landscape of Fear. Now we're all the way up on episode 745, so lots changed. Randall's hair has grown like that and been cut back.
That was just
dozens of times since then.
Just a few weeks before Corinne and I started, I think. So
yeah,
Phil was just getting out of high school. Kevin is here. So Kevin is the professor of natural resource sciences at the University of Wyoming's Haub School of Environment and Natural Resources, Department of Zoology and Physiology. He is the leader of the Monteith Shop. He is here to dispel almost everything you think. In fact, about deer, about deer and elk, about antlers. He dispelled it before, and he'll dispel it again in a new way, plus other things. All I do now when I'm talking, every time, and I had to do this the other day. I had to do this the other day. Who did I do it to? I'm trying to think. Oh, Morgan Potter, a professional hunter in Africa. He was laying on me the whole genetics.
Oh,
this area doesn't have good deer. This, not laying it on me. I don't mean to he's a buddy of mine. The whole that area doesn't have good genetics. And I had to lay on him the old, not so fast. There's a lot more to the picture.
You see him stiffen up there?
Did he stiffen up? He's itching to get into it.
Yeah.
Oh, not that I said, yeah. Lot goes into it.
I think it might have also been a reaction to some of the.
Listen, this isn't a weapon. This is an antique. I'll explain it in a second because it's relevant to my life right now.
Relevant to your life?
Yeah, I'll explain. Not really. For instance, just to give you a pretitillation about what's going to happen. Kevin's just showing me a picture of a buck, a mule deer buck. Anyone on the planet would look at this buck and declare it to be a classic year-and-a-half-old buck, a classic first rack, like a spiky little buck with little offshoots. You'd be like, that's a year-and-a-half-old buck. Every guy would say that. I would tell my kids, if they'd be like, is it a big one? If they got it, I'd be like, nah, that's a year-and-a-half-old buck. It ain't. It's 2.5 years old. At 3.5, you'd look at him, you'd be like, probably not a year and a half old, but still looks like that. A buck that'll be a runt for the rest of his life. Not because he's from an area with bad genetics. It's because his mom was in piss poor shape when she was pregnant with him.
Correct. That's right.
We're going to get into all that and a lot more. Lots of good research. Lots of good research. But first, we were just talking about how you call your place, your outfit, which is kind of fun. You call it the Monteith Shop. And we're talking about in the trades, you meet at the shop. I don't care if you're a tree surgeon, whatever, millwright, you go meet at the shop and then you go off to your job site. And it's funny that you called your scientific lab your shop.
Yeah.
because there's work going on there.
There's work going on there. Yeah, and we definitely catch some flack for it because it's not.
You do?
It's yeah.
Because it doesn't sound official enough?
Doesn't fit, right? Yeah, if you're going to be a scientist or a group that does science, the typical reference is a lab. And I think that's, at least in the academic world, that's the norm. And I think despite working in an academic world, I don't think I've ever fit the mold. I don't think I necessarily have a desire to fit the mold. And so in thinking about what it meant for us over time and who we were to be referenced as in that way, to me, what made more sense, if we're going to be data generators, hands dirty in the field, and being able to do the work that puts us in as close proximity to the animals that we do, to me, what made sense is a shop, something that's more that associated more with the trades, or like a mechanic shop, for example. I often maybe reference us as like diagnostic mechanics, working to hands dirty in there, working to figure out what's going on with any particular animal population, and working to understand them better. So, and I think, I don't know, I guess like my upbringing and who I am at heart, it fits a lot better than being referenced as a lab. So, despite the flack that we get for it, we've stuck with it.
Oh yeah, I wouldn't pay attention to that. Before I explain this here knife I'm holding, you got a Monteith Shop shirt on that has what I thought was a Bigfoot guy pumping iron.
You did think that, and it's not that. Correct.
Okay. What is it? Because this is something I hadn't heard of. I'm embarrassed to have not heard of it, but I haven't heard of it.
For as much as I hear you talk about beavers,
he's got a picture on his shirt of a Bigfoot pumping iron, lifting a stick.
Except it's not.
Yeah, it looks.
Bigfoot
It actually reminds me of the sand creatures in Star Wars when they shake their
Tusken Raiders.
Yeah, the Tusken Raiders when they shake their things at one another.
Yeah.
That's good. That's good.
Thanks.
Speaking of which, I'm trying to license a song right now that has a line. We did a couple favors for a guy who looked like a Tusken Raider. No, we did a couple favors for some guys who looked like Tusken Raiders.
Is this based on a true story?
I doubt it.
Okay.
Go on.
So it's a beaver holding up a stick. And part of that is the artwork was done by one of our former team members, Randall and Jacopek, and we just started doing some work on beavers here over the past couple of years, and sort of, we became aware of this behavior, and it's a behavior often that's very rarely seen in beavers, but there's a scientific paper on it, and if you Google stick display in beavers, there is a YouTube video demonstrating them doing it, but amidst like territory holders or at the edge, kind of the fringes of potential territories, that sort of antagonistic behavior, they'll pick up a stick and just go up and down with displaying that stick. And I don't know, I think it's kind of funny too, given that, most of our work is on big ungulates and we've done a good bit of work on horns and antlers and those sorts of things. Then what they're used as is weapons and forms of intimidation and display, and beavers don't have antlers or horns on their heads, but perhaps picking up a stick does some sort of has some sort of intimidation element associated.
Sure, dude. It's like he's getting pumped. That beaver's he's getting pumped.
Yeah,
dude.
exactly.
Speak softly.
Carry a big stick. No, that's exactly right. Our stickers have that saying underneath it: "Speak softly and carry a big stick."
Yeah. It's he's either, if you really dug into it. Is it like a fitness display? Is it like, hey man, like this is a hard thing to pull off, right? When we were at this, when I was just in Africa, we were hanging out with these Maasai dudes, and they have there's this traditional dance in Maasai culture where it's generally like young men and young women, and in this dance, there's like a display, an athletic display of men, which is just a flat-footed jump. Again and again. Like a spring, like from a flat-footed stance that you just jump again and again and again. And like get some impressive height, dude. Especially when I was like, let me give it a wing. I was like, oh. Yeah, impressive height. And then, right, it's just and asking like, what is it all about? It's just like showing
what you got.
Your game.
Yeah.
Yeah. A flat-footed jump, you know? And then for the women, it's kind of like you put this disc around your neck and it's like a gyrating move to make the disc shiver, right? It's just showing what you got. So that beaver could be like, yeah!
Exactly. Balance, strength.
Yeah. Or he's saying, I'm going to whoop you with this stick.
Yeah. Or it's like, this is the kind of stuff we got around here.
You know, I had a beaver interaction the other day. My boys, his buddy's family, they had beavers plugging up their crop irrigation system. And I went over to advise him on trying to get rid of them. And I made some castor mound sets. Just like took beaver's. It seemed like just one beaver kind of like doing his deal. Put castor out. He just left. I don't know. I can't prove this. I feel like he had like oh shit, someone's already here and left. I'm telling you, he left. He's gone. We keep checking. He's gone.
That's wild.
He had these little dams in a irrigation deal.
Yeah.
He had these little dams. He had a couple little shit and castor mounds the size of a cell phone. You know what I mean?
Yeah.
We put like two big old castor mounds, mounted cast on there, and that dude, I'm not kidding you, that dude moved out, which could be like something interesting to develop for like sort of like non-lethal deal is get after him early and just be like, sorry boys.
Making big castor mounts.
Yep, sorry boys. Yep. There's already a bad mofo in town, man. You better go find a new spot to hang out. So he, and it did him good because he's alive. He lived to tell the tale.
Mm-hmm.
Yeah. Oh, this knife. So Heather Duville's in town, A.K. Moosey. I screwed up in my head and I didn't think that she would be here. She could be hanging out right now, but I just didn't think about it. I didn't think, and by the time I invited her, we're recording at 9. It occurred to me at 8:40 to invite her. She wasn't able to make it. She's shooting pistols. But I'm going to have her fix this because she's a leather sewer. My old man brought this home from North Africa in Whiskey 2. That's like, got to be elephant ivory.
Yeah.
Take a look at that.
Oh, yeah.
That's awesome.
It's got to be elephant. I don't know what the hell. I don't know what kind of ivory it is.
It looks exactly like some of the stuff that I have from my grandmother that was from China. So.
From China?
Mm-hmm.
No, it's from North Africa.
No, I know. I'm just saying, like, a little Confucius statue carved in ivory.
Oh, I thought you meant that you were accusing my dad of bringing home some kind of souvenir knockoff.
Yeah.
He was going on the defense just like that. Where's the stick?
Yeah, he was real, like, whatever it was, I just don't remember what he told me about it. He was real particular about it, though. And this sheath is a weird leather. Look at that leather. I've had some people say maybe ostrich, but you can't see a lot of times in ostrich leather, you can see the
graining.
You can see the follicle for the feather. I need to have it stitched back up. That was unstitched when I was born.
Oh, so it's been that way.
It was you know what I just did? I took mineral oil. I took that sheath and put mineral oil, a couple tablespoons of mineral oil in a vac bag. And stuck that sheath in there and vac sealed it, which I'm going to patent as a way to like bring leather back to life. Picture what I'm talking about.
It's a good idea.
Drawing it in.
I'm going to patent it so no one else can do it. Unless they check with me. Take like an old leather belt, whatever, that's kind of played out.
Mm-hmm.
Put oil in a bag, vac seal it in that bag, then let it sit on your workbench for a couple days and open it up, and that sucker is rejuvenated. Now, a leather guy might tell me that there's a reason that's dumb or not a good idea, but I don't know.
Or he might tell you that people are already doing that.
He could tell me that.
Yeah.
He could tell me
And
you
it's
might
already
think it's a good
patented,
idea,
so
but
it's
don't be
illegal for you.
surprised. Don't be surprised when you pull something out and it fell apart. I don't know. But I think I'm on to something. But I need to have it stitched back up. But isn't that something? I want to, like those antique roadshow things?
Yeah.
Love that show.
Yeah.
Like, what is up with this thing? Randall wanted to know if he came home from the war and it had kraut blood all over it. But I don't know that he
see.
I told him I already cleaned it all off. Randall's got back from Germany.
Much to Steve's chagrin.
Yeah, I don't like that one bit.
Well, you're glad that I'm back.
Yeah, I'm glad you're back, but I was nervous the whole time you were over there that things might break out again. Norm Macdonald used to talk about that.
Yeah.
Everybody's always worried about like North
I know
Korea,
this bit, yeah.
Russia. He's like, why are they not worried about the Germans? They've already
They've
had
already
two
done
world,
it.
We've already had 2 world wars with them. Why do you think it's over now?
R.I.P.
Yeah. Oh, one other quick thing. I don't want to take up too much of our time, but you know how I'm bad on sports. I'm bad on like just generally very ignorant about athletics.
Mm-hmm.
I was getting my hair cut. I get my hair cut at VIP Barbershop, which is great. You got to call ahead, but it's great.
Mm.
And one thing I like about it is they always playing sports with the volume off, which sounds better, that way. And
because there's less of it.
Well, no, I like it. Like during the Summer Olympics, it was cool because you just watch these people run around the track, but you can't hear what's going on. I thought it was very soothing. I'm in there the other day, and like there's a huge TV screen. It's the only thing in there. They don't really. It's not really like mega decorated, but there's a huge TV screen. And so normally you sit like when you're getting your hair cut, you're looking at the screen.
Mm-hmm.
But when you're waiting, your back's to the screen. But the other wall is a giant mirror.
Mm.
And I'm just kind of lost in my thoughts, half watching a baseball game. But it's in a mirror, okay, which I didn't think about. And every time a guy hits the ball,
he's running to third base.
He'd run the other way. And I'm like sitting there, I'm honest to God, sitting there like, when did they change that? I swear, I was almost going to ask Kevin, the barber. I was almost going to be like, why do these dudes take off running like the other way that what you normally would run? And all of a sudden it occurred to me, I'm like, oh, it's reversed.
Yeah. Well, you're probably excited because he thought, boy, the prevalency of left-handers is really going up in professional sports.
Dude, I was so ready to open my mouth and go like, hey, why are they? Yeah. Could have been majorly embarrassed.
Could have been
at the barbershop.
Yeah.
Couple quick news bits here. Let me look here a minute. Oh, a movie's coming out. I can't believe I hadn't heard about this before. There's a movie coming out where Bambi goes and seeks revenge.
Mm-hmm.
You ever heard about this? It's called The Reckoning. Bambi, The Reckoning.
The trailer.
Well, everybody
hilarious.
says Bambi, but isn't it like Bambi's kid? How does it work? No, Bambi's dad gets killed.
Mom,
yeah,
right?
the mom. Yeah,
That's who gets killed?
Mm-hmm.
right.
No, it's his old man.
Yeah, there is. Yeah,
Maybe
is
they
old man.
both think.
Remember Spencer tried to work up how many inches of antler
oh yeah, yeah. Because
Bambi and his dad had?
the buck does get killed, but I feel like Bambi's also an orphan.
Right.
So
like
maybe
both
there's
parents
yeah.
They call
It's
it
been a while, to be honest.
It's a C-tier creature feature. I guess that means poor graphics.
It's made by the same studio that made a bunch of Winnie the Pooh horror films as well. It's like as soon as they enter a certain form of public domain, they just go buck wild on these things.
Interesting.
Yeah, so the story is like it drinks some toxic something or other, and then it becomes monsterized, and it has like a million.
Just like Ninja
Teeth.
Turtles.
The grieving deer decides to take a sip of the nefarious chemical that local corporation Wilburks. There's always a lot of these movies. There's animal movies. There's usually a bad corporation.
There's a strain of anti-capitalism in all of these.
Oh yeah, my kid's in this little song and dance club right now for a week, like just to keep him busy. My little one, just to keep him busy before we go to Alaska, And he's coming home singing. They're teaching him a song. It's like a flat out like anti-capitalist song. He comes home every night and practices.
Is it the one from the Lorax?
Yes.
Yeah. My kid's at that same song and dance club.
Is he?
Yeah.
Oh, what's his name?
Well, I've got two kids in there right now. I think Yanni's daughters have done it as well. Yeah. It's a good
so
time.
you think your kid and my kid are in the same song and dance club right now?
It's very well. He's not doing the Lorax song.
They're comrades.
He's doing
They're not
Aladdin.
in the
They're
same
comrades now.
There's different age groups, and it's not like the Lorax was a book written decades ago
No.
with the same
song-
exact anti-capitalist sentiment and
The
same plot.
song has nothing to do with the Lorax book. It's a guy with corporate attorneys. It's like has nothing to do with the Lorax book.
Well, yeah, but it's about him cutting down the trees to make the thneeds, and he's draining the resources dry without a thought of the planet or
No, that's
or
not in the song.
Yeah, well,
I invite you to
gotta
look at
read
the
between
song.
lines. Is it the one that says how bad can I be?
Yeah.
Yeah.
And it's like he's like talking about his corporate attorneys are denying, and
Yeah.
like it's like this whole. Either way, so
Next week it'll be the Internationale.
um,
That wouldn't land.
one
It's over my head, Randall.
I don't get it. What's the joke?
That's the old, isn't it the old socialist anthem?
Oh, I don't know.
No. Sorry.
Kevin, you got stomach for one more news bit?
Yeah, you're
Was
good,
that a
man.
news bit? Yeah, it was a news
Yeah,
bit.
yeah.
You're good.
Coming
Bambi, a
features.
Bambi movie's coming out where Bambi becomes a fanged, bloodthirsty monster who will stop at nothing to attack his prey.
Hmm.
And there. Yeah, it's
Stay
news.
tuned.
And are his prey humans? Or we don't know.
I'm assuming.
That's
I'm assuming
Yeah.
there's a lot of blue collar men.
That's
Yeah, because, well,
driving around in trucks.
before, like, there's a whole genre of these movies, like animated animal movies.
Yeah.
There's a whole genre where the bad guy is a southerner
Mhm.
who hunts.
Mm-hmm.
You know, I've talked about this one show a bunch of times. There's this show my kids used to like. I didn't like them watching it, and there's like there's like rotating cast of bad guys. One of the bad guys was a wild game chef. One of the bad guys was like a very
That's pretty tame.
yeah, he was a very like effeminate urbanite. Yeah, and one was like a southern chef.
Huh.
The villains.
Huh.
Okay. We've talked about on the show. This is news-ish. We've talked about on the show and demonstrated in various video projects we've done the process called Ike-Jime. You familiar? It's a fish dispatch method.
Oh, no.
My first introduction to Ike-Jime was not by, it's a Japanese word. My first introduction to Ike-Jime was not having anything to do with the Japanese and not having anything to do with fish. But it was demonstrated to me in South America with a giant river turtle, which is a CITES species. But these native dudes had a net, and they were using the net to catch fish. And this big turtle gets wrapped up in their net, a giant river turtle. And we're in a camp together. They take the turtle. We weren't able to film this because they were explaining to us that like it's kind of a no-no, but the turtle had gotten the net, so what could they do about it? Even though they could what? Either way, they go and cut a switch, like a big slender stick, and peel the bark off it, and basically make like what would look like a hot dog roasting skewer, okay, or like a marshmallow stick, and take the turtle and flop, cut his head off. Now, when I used to process turtles, we would cut their head off, and then you hang them up by the tail, and it would be hours before you could pull his leg, and his leg didn't suck back into his shell. Right? You'd hold out a pair of channel locks. This is how my dad taught me to do it. It's kind of gruesome, but it's just how Escoffier explains it in Le Guide Culinaire. But you hold out a pair of channel locks, so the turtle grabs the channel locks, grabs onto it, and you pull out and decapitate them, just like you're cutting the head off a chicken. This is just how it was demonstrated to me as a child. And then you hang the turtle up. And eventually, you pull his leg and it doesn't pull back, and then it's time to clean the turtle. These guys in South America, they took a machete, flop, and then took that long skewer and inserted it into the spine and ran that skewer all the way down that spine till it was in its tail. And that turtle melted. I mean, melted. It was just like
That was
blubber.
after they cut the head off.
Immediately. Cut the head off, ran that skewer.
Huh.
And there wasn't, because like a turtle is I don't know what's going on in the nerve. Like,
It's just like disrupting all the nerves.
Yeah, like think of the expression like running around like a chicken with its head cut off, which I mentioned to my kids all the time when we're hunting. Like they'll hit something and it'll kind of do a little mad dash and they feel real bad for it. And I'll be like, well, think about it. Like someone cuts a chicken's head off, it runs all over hell, right? It's like dead, but not dead. So, it just like, it melted the turtle. I've never seen anything like it. Turns out this is a common fish dispatching method in Japan. And I've gone with a friend of mine. She was Korean, but still, she would catch a fish and immediately cut its tail, just cut through the tail to sever the backbone, the spine at the tail point, right? And then you kind of cock the tail so it's still connected by skin, but it's now cocked back, folded over. And then she'd take this brass wire she had, copper wire maybe, whatever the hell it was, copper wire. She'd take this copper wire and just in that spine. You following me?
The spinal cord. They're basically going.
And that fish just
reaming the
like
spinal
just
cord.
is like done.
Yeah.
You think of a fish flopping for a long time, whatever, and it influences how that fish goes through rigor.
Yeah.
And it's just like the fish is just deader than dead. This guy here, there's this company, Shinkle Systems. They've built a robot that uses the Japanese ikejime method of killing fish, which they regard as the most humane way to harvest the animal while producing the best quality meat. The process involves inserting, I forgot this part. It's kind of like an ancillary part of the thing is you put a spike in the fish's brain first. So the process involves inserting a spike into the fish's brain as soon as that is caught, killing it instantly, reducing the stress that can cause the fish to spoil more quickly. Hold on a minute. Oh, he's not talking about what? That's what he's talking about? Not running the... Hold on a minute. Randall, anyone? Their machine isn't the spine reaming machine.
No.
Their machine is just the spike to the head machine.
Do you need a machine
Yeah,
to do
That
that?
seems
It
a lot
stuns the
easier to make.
It stuns the
Yeah.
fish to help humans do that method.
No. So it's a robot that stuns a fish?
Yes.
This is what you get for talking about news articles you haven't read. Do you know what I mean? Like, people are always saying, like, well, I read an article this morning, and I'm
Yeah.
like, I always go like, I didn't really read it. I mean, I saw it. Oh. But the
Yeah.
guy says a weird thing. So he's talking about how he's what?
Huh?
Okay. Oh, making the subsequent cuts in 7 seconds. Is he reaming the spines or not?
The human does it. The machine stuns them. And
Shinkle's refrigerator-sized machine called Poseidon is operational.
Steve reads news, so you don't have to.
Is operational on 3 fishing vessels off the U.S. West Coast. The fish is inserted into the robot, which then uses computer vision to identify the species and its anatomical information, spiking the brain and making the subsequent cuts in 7 seconds. It might be that this is a bad writer who wrote what I'm reading.
Clearly. Subsequent cuts makes me think that it's doing more than...
That it's reaming the spine.
Yeah.
This guy raised $22 million for this thing.
Raise
Should have gotten
But he
into
has
robots.
you know what really turns me off though is one of his quotes. He's got a quote that I think is indefensible. Where's this quote? Oh, here's a quote from this guy who bills himself as former SpaceX engineer. But I don't see SpaceX engineer and think fisheries.
Mm-mm.
Primarily because they're very interested in Mars, and there ain't no life on Mars. Like, I don't want to go there. You know? He says, we've been fishing for 40,000 years, and the tools haven't really changed.
Little bit of an oversimplification.
Are you at all aware of a thing called sonar-guided bottom trawling? I mean, holy cow. He's saying that, like, nothing's changed in 40,000 years, but now we have a robot that can poke a hole in the fish's head, and this is like the right direction. I'm like, nothing's changed in 40,000 years of fishing?
Yeah.
Good Lord.
Plastics, internal combustion engines.
Sonar-guided bottom trawls, which can literally scrape underwater spires. Whatever. There's another big article about lab-grown meat and fish, which Corinne put in here and then pulled out, and then now they're back in here again.
We don't have to cover it.
No, we're not going to cover it.
Okay.
I don't care if everybody eats it. I don't want it.
Well, this was more on the lab-grown fish that it's making it's getting into some good restaurants or
I don't know if I buy
restaurants in Portland. And there are 7 states that made it illegal. And the news bit is that last month, Texas was the 7th or 8th state to ban it.
Our own great state made it illegal.
Mm-hmm.
Florida, Alabama, Arizona, Tennessee, Texas, Indiana, Mississippi, Montana, Nebraska have done various things to like prevent or slow down or ban cell cultured meat. Mm-hmm. Texas just did it in June.
Yeah, I thought they maybe
that's
would have been earlier.
That's a little bit Big Brother for my likings, but like I can't get worked up about it because I'm kind of grossed out by lab grown meat. But Corinne, by saying good restaurants, think about what you're saying though. The article is pointing out how a Haitian restaurant in Portland is serving lab-grown salmon. Now, I haven't been to like Haiti recently, but is there like
Haiti?
a lot of big Haiti? What did I call it?
Haitian.
Yeah, tells you how long it's been since I've been there. Is there like salmon isn't part of Haitian cuisine?
Good, by
much
good,
less lab-grown salmon.
It's the chef is won a James Beard Award, so I think that puts him at some kind of level.
I've been nominated for James Beard Awards, and I don't feel like I'm at any level. Okay, you ready to dig in?
Sure.
All right. How do we start? Because you guys do so much work, man. Can we start with a recap?
We can do whatever. We can start with a recap. What kind of recap do you want?
Can you recap for us and our listeners? Just kind of like, I'm sure you give the spiel all the time. The spiel about when we see an area that we declare like bad genetics or bucks don't get big there, that area's got big bucks because it's got good genetics. What is that shorthand for? You know what I mean? Like what are some of the things that actually in your mind, and it could include genetics, but like what are the sort of hidden factors that are driving whether you're seeing big giant bucks in your part of the state,
Yeah. Well, I mean,
is that too big of a question?
No, you're good. I'm just trying to figure out how to lean into it. Age, genetics, and nutrition affect antler size.
Tell me again.
Age,
okay.
Genetics, nutrition.
Okay.
And much of our focus for a long time, and certainly within hunting communities as well, we tend to offhandedly and frequently refer to genetics, right? It's hard to open up a magazine and see an article written, about some big buck or big bull that somebody harvested, and inevitably it's like, man, the genetics in this area are just fantastic,
Sure.
for large antlers. And there's an aspect of that is true, like to grow, a substantial set of antlers, horns, you need to have genetics that support that, right? But we also get ourselves in this situation as we frequently refer to that. And I think where some of that's come from is we've called it our hornographic culture, where we're so focused on horns, antlers, their size. Like, we're so drawn into that. All we can think about is males and the crap that's growing on their head. And so we've referenced that as our hornographic culture. And there's elements of that are good. That doesn't.
Dude, I
love
just saw
that.
the greatest
Males
shirt,
and the
dude.
stuff that's
Hornography?
growing on their
Hornography?
head. Yeah.
Can you text someone right away before someone steals this idea?
No, this is going to
It's
Hunter
a buck
Spencer.
mounting, a buck mounting a doe, and it says hornography. A big buck.
And proceeds go
All
to
right,
Monteith Shop.
texting
And then
Hunter right now.
and
See?
yes, that's perfect. Proceeds go directly to me. Proceeds go to the Monteith Shop. Is that fair?
Yeah, 100%.
You don't care if we steal that?
I didn't clear
No.
that with,
Well, yeah, but
with
he
the brass.
said-
I just sort of threw it out there.
No. That's how we're going to do it, I
Yeah.
think. No, that's how we're definitely going to do it. 'Cause
Good,
we just stole it flat out from the guy in a recorded place.
We've used that term in a scientific paper, in 2 scientific papers. I mean, we laid it out in a scientific paper.
All right.
So
here,
it
here's the deal.
exists.
Can we do the thing, and then if we do, proceeds go to you guys?
Yeah, 100%.
Hornography. That's good.
I know when I see it.
Sorry, continue
No,
on.
no, you're
I just
good.
got so damn excited I
Yeah.
couldn't even contain
Yeah.
Text
myself.
is into Hunter.
So I think what that does is and of course, like when you take that scenario where we're focused on the males, and then we think about like what has happened, for example, in places like Texas. We often think of like Texas and line breeding and the various things that they do to get males to grow these just ridiculous sized antlers at a very young age. And there is a genetic element to that, but I think that's part of what's just translated to us is, well, of course, if there's big antlers in this area and not in this area, there's better genetics over here for antlers than there is over in this other area. So what we did to better understand what aspects of genetics versus nutrition go into producing large antlers is, I think, it's fortunately like one of the most, I think, elegant experiments that I've ever been able to be a part of, and that is some work we did in South Dakota. And with that work, we had animals in the Black Hills of southwestern South Dakota, which had historically been known to grow some impressively large white-tailed deer, a number of bars and Custer and other places that have just stupid big white-tailed deer. But more recently, in the past number of decades, they're all very small. Like, we just don't grow big deer in that region anymore. Versus in eastern South Dakota, where we can grow impressively big animals as little as 3 to 4 years of age. And so the looming question with that, and it presented the situation to evaluate what you referenced directly, and that is, are those animals in southwestern South Dakota in the Black Hills just genetically different than animals from eastern South Dakota? So we did what we call a common garden experiment, brought those animals into captivity as newborn fawns. So we captured animals from the Black Hills in eastern South Dakota as newborn fawns, fed them, put them on a high nutritional plane. So we bottle raised them as fawns, put them on a high nutritional plane. So we basically maxed out nutrition. Okay. Nutrition wasn't limiting in any way. And then raise those animals all the way up to adulthood. And at adulthood, animals from, on average, so once they hit peak body mass, antler size, animals from the Black Hills, males from the Black Hills were 70 pounds smaller than males from eastern South Dakota and had 40 inches of less antler than animals from eastern South Dakota.
Because of bad genetics.
Because of bad genetics. Right? And right surface level, right?
Yeah,
well,
like,
they've been on good nutrition since the day that they were born.
Yeah.
And so clearly that supports a genetic explanation then at that point.
100% case closed.
Case closed. Which then we took that one step further and looked at the next generation of animals born in captivity. So we had Black Hills males and females, allowed them to breed males and females from eastern South Dakota.
So like no local bucks jumping over the fence.
No local bucks jumping over the fence. Yeah. No, we allowed them to breed within their groups from all the animals that we'd raised since newborns. And then raised that second generation of animals all the way up to adulthood. And so once that second generation of animals were raised all the way up to adulthood, if we just consider the Black Hills animals, those sons born to those Black Hills males that I was just talking about, those sons had 30-inch more antlers than their fathers and were 50 pounds heavier than their fathers, indicating they made up over 70% of the difference that occurred between the first generation animals that we brought into captivity. We didn't do anything genetically. Same genetics from those two groups of animals. What was different was the mothers from the animals that were now born in captivity, that second generation of animals, those mothers were on a high nutritional plane. Now, if we go back to the wild scenario, when we originally got those animals, the mothers in the Black Hills were on a poor nutritional plane. Ponderosa pine-dominated forest, crappy understory, just on a poor nutritional plane.
Yep.
So what that means, it's called the negative maternal effect. What that means is that those animals that we originally got as newborns from the Black Hills carried the nutritional signature of mom who was living in the Black Hills.
Yep.
And now our new animals that are born in captivity, they're now carrying the nutritional signature of the moms that they're born to in captivity, and those moms are on a high nutritional plane. And there's almost no, I mean, when you think about that level of difference, I mean, we're talking 50 pounds difference in body mass, 30 inches of antler. Like, it's pretty wild to think that we could, through some genetic manipulation in a natural setting, obtain that level of difference. And here we're talking over a single generation of animals, those massive increases in both body size and antlers that are attributed exclusively to nutrition of mom while those young were in utero.
Yeah. Yeah.
And so, and even like there's been a number of studies that have been done in Texas from some colleagues of mine down there where they've, gone to great lengths to manipulate genetics by within enclosures, by taking, helicopter catching males and then culling males that weren't meeting the level of size that they were working to obtain, and are basically unable to obtain a positive change in antler growth over time through that level of very directive, very selective culling.
Yeah.
So when you think about that, when we translate that to like one area to the next, then what that can mean is that, and there's two sides of it. One, each set of these animals is adapted to their local environment. Not every environment has or offers supreme nutrition, right? So if we consider place in the arid desert to, a migratory mule deer populations that's running up into the high alpine and, eating tall forbs all summer long. So all these animals, in the arid system, maybe their winters aren't so bad. So that it doesn't take as much for them to persist through winter versus the animals that are in the more temperate systems in the mountains. Like it's harder for them to persist through winter. And so even if you just consider that at the surface level, not all of those animals can just operate and do the same thing. Mm-hmm. The way in which they operate, the way in which they obtain and allocate resources has to be adapted to that local environment. So there's a side of that that's influencing antler size that we see from one place to the next, but it's also a reflection of that local adaptation, the nutrition they have present there, and their ability to allocate resources to antler development versus other things. So certainly when you consider like males in one region to the next or males in a harvest from one area to the next, like if we're going to compare apples to apples and say there's bigger males here, smaller males here, we first need to, of course, consider what age classes of males are there, right? If they're mostly 2 and 3 year olds versus over here, there's less harvest and they're mostly being harvested at 4 to 7, we're going to see differences in antler size. But once we've accounted for that, nutrition and what we see from one place to the next is going to play a much bigger role than genetics from one place to the next. And most of that nutrition and what dictates what a male is going to be for the rest of his life is mom and mom's condition in utero. Yep. So I think what's fascinating about that is then what we see, and even as we see from one year to the next, we can see fluctuations in antler size given environmental potential from one year to the next, food growth, spring conditions, summer conditions, winter conditions for that matter, from one year to the next. The greatest marker of what a male carries with him actually came before he was even dropped on the ground.
Yeah, that's a buddy of mine in Wyoming, a guy that's very, very shrewd on wildlife and like a lifetime observer of wildlife. He was, I didn't get into it with him, but he was talking about it was a wet spring, right?
Yep.
Anticipating good antler growth.
Yep.
He's not wrong though, right? I mean,
He's not wrong.
that is helpful. But you could also, like, a thing you wouldn't hear from a guy is the guy wouldn't come and say to you, 2 springs ago,
Correct. Would not.
I saw a lot of fat does.
Yep.
So I'm hoping to draw a tag this year in order to reap the benefits of that great nutritional season that those does were enjoying some time ago. It's just not like part of the lingo.
Correct.
You know?
Yeah. And so, which is also important for us to be mindful of as hunters and even as conservationists. When what we see today, for example, from yield of males or even size of males within a population, in many instances isn't a reflection of what happened then or what happened over the past couple of years. It's actually a reflection of what happened maybe 5 years ago. And it's in large part because of the conditions that those males experienced from their mom while they were in utero. And it's called a cohort effect as well, where we may have years that were just poorer years or worse winters where moms were struggling in utero and they lacked the ability to give their young the silver spoon right out of the gate. And so that signal, even if conditions improve later on in life, just like our example with the common garden experiment, even if condition for that male gets better after that spring and summer, he's still going to carry the mark of mom's nutritional signature with him for his entire life. So when that cohort of males gets to 6 years old, they're going to carry that signature. And so especially when we see
I wasn't thinking, but it's even more delayed.
It's even more delayed. And so as we consider even ups and downs and fluctuations within populations, for example, we see reductions in density, and we can talk about this too with like bad winters, and then we see nutritional recovery within a population, meaning we have a bunch of fat moms that are able to, to plug into their offspring. I think what's really interesting is oftentimes in periods of population growth, we'll then see, in a few year lag behind that is when we'll see a number of very large males being harvested. And it wasn't
that again. What's the timeline?
So if we see a dramatic reduction in a population, for example, and so that reduction is then tied to reduced competition for food, so nutrition improves.
So like a big winter kill.
Yep. So nutrition improves for everybody else that remains.
So there's a big winter kill.
Yep.
Wipes out all the deer.
Yeah.
The 20% that are still standing have it gravy now.
Yep.
Because they got all the good bedding areas, they got the good feeding areas.
Yep.
All to themselves.
Less competition for space and food. Yep. So nutritionally, they're far better off, which means they're meeting their needs, and then those females are able to allocate more resources to their offspring. So those offspring, and I mean we see this in our work, born bigger, grow quickly, and then they're carrying that positive nutritional signature with them, right? We're not going to realize that positive nutritional signature from a male harvest perspective until maybe 4 years down the road, right?
That's a thing in my little point I was making that it wasn't even accounting for.
That's correct.
Is you'd have to be, I'm excited about this year.
Yep.
Because 4 years ago.
Yep.
Yeah.
Yep.
There was some big fat dough.
Yes,
and then
that's exactly right.
There's kind of like two like countervailing forces then with a bad winter, because I think like the traditional understanding is like there's a bad winter and then you have to wait for the bucks to backfill. Like, so the 3-year-old deer, the old bucks die, the 3-year-old deer become 4-year-old deer, become 5-year-old deer, and you see that sort of, but then in a bad winter, those bucks that are born after the bad winter are going to have that limited potential for the rest of their life. But then the bucks born after that are going to have much better potential than the ones that died in the winter. So there's like a stunted generation right before that generation that's enjoying the more food at the trot, that kind of thing.
Phil, can we try to animate what Randall just said?
Yeah, I'll get
with
right on
charts
that.
and graphs.
Yeah, sure.
Can you say that one more time?
Well,
I know because you're a very smart person.
thank
I
you.
know that you're right. I just don't understand what you're saying.
We should have a chalkboard in here.
Oh, that'd be great.
No, like you know, like the traditional. I think like the traditional, very simplistic, like logic about Winterkill is that old bucks with worn down teeth are going to die,
Okay.
and then that unit. If you're just talking about like a unit, you're saying like, okay, that unit will be back on its feet by the time the younger bucks get to that age class.
Yeah, I would say
right?
that. I would say that.
And so it's sort of this like linear like backfilling. But once those bucks get to that age, then you have the generation that were still in mom during that bad winter. So that generation is going to drop.
Yep.
And then the ones from the generations after that, then they're going to have even more food than anyone. So there's almost like a delayed onset. There's like a drop in potential and then a skyrocketing potential in terms of those cohorts. Does that make sense?
Do you think he's sitting on a publication here?
I don't think it's nearly sophisticated enough to make it a Monteith Shop paper.
Well, so let me. I can essentially describe that with what we observed. With
I'm tracking.
Randall's
I'm
second
going
time.
to get out my markers.
The second time I'm tracking. Yeah.
With what we observed in the Wyoming range. And so I want to say before I get into that, so we've been working in the Wyoming range now since 2013.
But can I a quick question? I want to hear all about the Wyoming range. There's one thing I want to clarify.
Yep.
Because you kind of got at it, but I just want to make sure you get at it.
Yep.
Your job is not producing. Your mandate is not to help hunters kill huge bucks.
No.
Okay. So let's clarify. Do you know what I mean? Like what is your sort of what gets you up in the morning? It's not like guaranteeing hunters bigger bucks.
Yeah, no.
Okay.
Yeah. Okay, I'll let's sidestep and get to some of those things, and then I'll swoop back to our deer work in Western Wyoming.
Great.
So, our motto is advancing science and management one data point at a time, and so that even ties back to like the reference to our name, and that our aim is to advance science, which means one way to think about that is our goal is to better understand what makes these animals tick, how they make a living within the world that they do, and then take that from just like an ecological standpoint, better understand them, and then two, what does it mean for us from a management or conservation perspective? The reference to one data point at a time is, we often joke, like the amount of effort we'll put into one single data point, because our work is typically, if we can pull it off, is long-term and it's individual based. And so that is, we're working to monitor individual animals for as long as we can.
Mm-hmm.
So a lot of studies like toss a collar on an animal, monitor for a year or two, and that's it. Well, yes, we're using collars, but we're monitoring them for as long as we can, and we're collecting a whole suite of other information on them.
Yeah, you're monitoring generations of deer.
We are. Yeah, that's exactly right. And so to do that, and so, for example, like one animal in particular, it may take a lot of money and a lot of effort on our side of things from a field perspective to monitor that one animal, to collect the data point from that one animal. But sometimes that one animal is such a critical data point to better understanding what makes those animals tick. And then if you take a whole bunch of those individual data points from animals and you pool them together, it allows patterns to emerge for us as to what it means for those animals. Notably, I'm very fortunate to get to be the spokesperson to talk about our work a fair bit, but there's so much that happens behind the scenes that I shouldn't get any of the credit. Our funding sources, we can't do what we do for free, and so we're also constantly raising money to make that possible. But Wyoming Game and Fish Commission in particular has had a lot of foresight to support us in some of these long-term studies. Groups like Muley Fanatic Foundation, Wyoming Wildlife and Natural Resource Trust, and many others that have been the backbone that make it possible to do what we do. And then all of the field personnel, especially with the Wyoming Game and Fish Department, are central to our ability to be successful and support us in the field. And then I work with an amazing team of people in the shop, grad students, research scientists that pour their heart and their soul into the work we do, the data collection that make all this possible. So want to be able to at least give credit where credit is due.
Sure.
And then if if I say anything stupid through the course of this, it's totally on me. All the good things that are said, they should all get the credit for.
And to put a finer point on this, like when you say one data point at a time, what you're doing is catching animals by the dozen, and every single one of them, you're taking temperature, you're measuring fat, you're swabbing the nasal passages, you're ultrasounding for pregnancy, you're measuring the size of the fetus. I know I'm missing stuff there, but
Yeah.
like I've gone on a collaring, or I guess a check-in and collaring thing, and it's hands-on and it's very specific. It's like, how much does this animal weigh on this day of the year? So yeah, like I think just to bring it to a more concrete level, like you're measuring deer,
Yes.
and handling deer, the same deer in some cases for years.
That's correct.
Yeah, it'd be like a thing. If you go back to the landscape of fear, and we'll move on from the old times. We'll talk about new shit. But if you go back to the landscape of fear, Kevin explained that you put a collar on a doe. You put a collar on her fawn.
Yep.
You track her fawn through her whole life.
Yep.
Put a collar on her fawn.
Yep.
You're starting to get a picture of where did that doe ever go? Where does the fawn ever go?
That's right.
Does the fawn go to new places or the same places?
Yep.
When? What are the movement patterns? What are their sort of relative fitnesses?
Yep.
Because you're able to look at like how fit was doe A? What's the condition of her fawn? What's the condition of her fawn?
Yep.
Right. It paints an amazing picture.
Yes.
When you compare it to a different style of biology, might be like we flew it with a helicopter and did a count.
Yep.
Right. It's just different. And I'm not dogging on that kind of work. There's probably great work, but like to go like, well, let's look at like a lineage. Like let's look at these like specific animals over a long period of time, and what can we tell about those specific animals that might inform what you're seeing when you fly over in a helicopter and count.
That's right.
Right.
Exactly.
It's like you're adding a really important piece to that can plug in or inform all these other methodologies.
Yep. That's exactly right.
Like when I went with you, I mean, it's your team members are like 20, 30 people all sleeping in the same Forest Service cabin, like rallying out into the field every day.
Yeah.
I'd have a no drinking rule.
Wrestling deer. And at night, like someone's making spaghetti and someone's, whatever you call it when you spin the blood vial around.
Centrifuge.
Your centrifuge. Yeah, like it's literally a Forest Service cabin and someone's making spaghetti and someone's centrifuging mule deer blood.
Yeah.
And then everybody wakes up at 5 a.m. and rallies out again. And a long day, like in February in Wyoming, just like someone's got a clipboard and someone's measuring deer and someone's sampling stuff. And it's just like, it's an impressive operation.
Yeah. Well, and I think like even as you described, Steve, the ability to connect those pieces together, which I hope is like more from like a mechanistic perspective, like how are these things happening? Why are these animals doing what they're doing? The sort of the getting under the hood perspective as to what it makes for each one of those animals to tick, and then as we scale that up, what that means for understanding what's going on within the population. That can't happen with like a 2-year study.
Yeah,
right.
Exactly.
We're talking many years to be able to put that together. And some of our goals with our work in the Wyoming range, so we've been fortunate to work there since 2013.
Yeah, let's talk. Let's set that up. We're going to talk about a specific place.
That's right.
So, do you mind? What is the Wyoming range?
Yep.
Where are we talking about?
Yeah, so Wyoming Salt River Range, Western Wyoming, and it's home to what either is or has been one of the largest mule deer populations in the world.
Region G.
Region G. Yeah.
Okay. Like you might, and if you hang out on mule deer forums.
Yep. There's a lot of talk about
a lot
the
of talk
Wyoming range.
about Region G, and a lot of the talk about Region G is speculating about its future.
Yes.
Talking about its challenges, anticipating what are going to be the good years, the bad years.
Yeah. It's under the microscope.
It is a very discussed unit.
Yep.
One of the reasons that's probably true is because it's like a unit that sort of occupies a distinct geographical feature.
Yes.
Right? It's like when you say Region G, you're kind of talking about like a range.
Yep.
You know?
Yep.
It's very elegant.
Yes.
And it is probably in the top 3 or 4 mule deer spots that get discussed, be like the Kaibab.
Mm-hmm.
I'm trying to think of the Henry Mountains in Utah. People like talk a lot about.
Yep.
Region G gets talked about.
Yep.
And mourned, celebrated.
Yes. Yes, for sure. All of those. Yeah. And so that population, I mean, is thought to have numbered, beyond 50,000 deer, once upon a time. And then kind of leaning into the 92, 93 winter was a time when there were thought to be well over 50,000 deer within that herd.
Wow.
There was a lot of female harvest that was happening at that point in time to work to bring densities down because they were over what Game and Fish define as the herd unit objective.
Okay.
The 92, 93 winter hit and the population crashed. And then since then, it's kind of fluctuated. I don't know if whether numbers matter or not, but maybe like 30 to 40,000 ish somewhere in there. And
on the high end,
and hasn't risen to those levels previously.
And what would be a low end since 92? So if let's just accept.
Yeah,
I know you're saying like maybe 50,000.
Yeah,
if we accept like around 50,000 in 92,
low end since then.
Yeah, like it hasn't hit that height.
No.
Again.
No.
So the new high end since then has been 30, 40?
Yeah, probably mid 30s.
And what would you ballpark has been like a low end
the
since
bottom.
then?
So I'm going to get to that.
Okay,
but
cool.
11,000. Yeah. So we started in 2013 doing the things that we do, as Randall described, to work to understand nutritional dynamics in the herd and then simultaneously just better learn more things about deer that we haven't learned previously. From 2013, and this was at a time when maybe, I forget the exact numbers, we're probably bouncing around in the upper 30s, maybe around 40,000. And from 2013 to 2016, what we saw each year was just a general decline in body fat of females, both in March and in December. So autumn and spring body fat. It just declined from 13 all the way up until 2016. And then in 2016, 17, we had a bad winter. We lost 30% of our adult females, pretty much all of our radio marked fawns. And so in going into that winter, autumn fat going into that winter was around 7%. So remember 7% body fat. We lost 30% that year. Population began to rebound after that. Body fat of levels of female shot way up. And then we had another bad winter in 18-19, lost 30% of our adult females again.
Sorry,
and
2019.
2018-19. So the 18-19 winter.
18-19.
Sorry.
We're working on a history project now. So
I live. Me and Randall live in
we're thinking across centuries right now.
So say the dates again. I'm sorry, that was dumb.
So
dumb of me, not dumb of you.
No, you're good. So winter
2018, 2019.
Yeah, so winters overlap calendar years, right?
I understand.
So 16-17 winter, 18-19 winter. Two bad winters, roughly 30% of adult females. After each one of those years, we see upticks in nutritional condition following that. So body fat of females shoots up after that. Productivity eventually returns. There's always a lag in a year because what ends up happening, this goes back to what you were referencing, Randall. So in those bad winters, fawns, because their metabolic demands are different. They're some of the smallest animals on the landscape, and they don't come into winter with much body fat. And this all comes down to allocation-related principles, right? And so as a fawn, the energy you obtain is mostly going to grow. You don't have a bunch of like extra energy to put in body fat. Versus females, adult females are done growing, and whatever extra energy they have, they can put into body fat. Or males, part of the reason why we see age-related dynamics in antler size or horn growth that we do goes to the same principle up until they reach asymptotic body mass and so are thus basically done growing in body size. We don't see peak antler size until after that. And that's all principle of allocation. They're first prioritizing
that's interesting,
body
man.
growth.
Yeah.
And then so even those age-related dynamics, yes, it's age, but it's founded in nutritional principles and how the resources they have and how they allocate energy. So even that's driven by nutrition.
I want to restate that point for people that are at work and they're only half paying attention.
Yeah.
Or me driving down the road listening to something. I'm listening to Clay's Water Witching episode right now, which is fascinating. But I only catch half what he's talking about because I'm driving. So if you're driving and you're only half listening, this is good. When a buck throws his I never thought about this before. When a buck throws his biggest antlers, he's at a point where he's seeing the least amount of body size growth year over year.
That's right.
So he's like growing his body, growing his body, growing his body, growing his body. Boom, he's kind of what he is.
Mm-hmm.
And then he gets serious about antlers.
That's right. Exactly.
Huh.
That's right. Yep.
All right, you can get back to work now.
All right. No, you're good. So after those winters, we see that uptick in body fat that occurred thereafter. But during those winters, we lose almost all the fawns. The females are in poor condition as they exit winter. And then what we see are spikes in stillborns after those bad winters.
Really?
And we see suppressed birth mass after those bad winters as well, which again, yes, I'll say this over and over again, but that has nutritional underpinnings as well. For a mom, for these long-lived idiroparous animals, which just simply means they live a long time and they reproduce multiple times through their lives, their best strategy is to have the opportunity to reproduce multiple times as opposed to take one instance and pour all into reproduction, because then they're likely to die. If they die, then they lose out on all those other opportunities to reproduce. So what that means for females that are in poor shape, it's better for them to survive and for their offspring to die than it is for them to pour everything they have into their offspring and then compromise their own survival. So that's part of why we see
because if she lives, she might crank out 3 more or whatever.
Conditions will get better next number of years, and she's going to have the opportunity to try again. So we see increased rates of stillborning, suppressed birth mass. Birth mass plays a huge role in whether or not they survive thereafter. And so what that means is you have high rates of stillborning. In fact, in some of those years, it's like the leading cause of fawn mortality after those bad winters. And so...
And that just because, like, that fetus it's not getting fed,
malnourished essentially,
malnourished in the womb, and dies exactly in the womb of malnourishment.
Yeah, that's exactly right, and they're born dead.
Man, that's another thing I never makes total sense. I just never really thought about that. I just never thought about the fact that a doe would like get pregnant, but then not have a fawn.
Right. Oh yeah, no, for sure. And I think to sort of sidestep, I think it's also important to point out, for deer in particular, both white-tailed deer and mule deer, they very rarely abort. So they will typically, once they're pregnant, they will almost always carry it to term, but then they may drop stillborns, for example, in those years with those bad conditions. We have, when it's gotten really, really bad in those bad winters, we have seen a couple of premature abortions that have occurred, but it's very rare in deer.
Okay, so she births it.
She births
at
it
the right time.
Yep, but it's stillborn. It's dead. And so a deer's strategy is to typically carry to term. So they're almost always pregnant. Twinning is very common. And then they'll typically make those sort of like nutritional decisions of if they can do it once the young have hit the ground. And so that's why we see that. Versus critters like pronghorn or moose, for example, where if things get really bad, they're more likely to just abort on the way. Or for critters like maybe moose, elk, sheep, we see nutritional signatures more strongly tied to like how fat they are and whether or not they're going to be pregnant. So those things are evident along the way. Regardless, what that means is we're almost missing 2 cohorts of young in those instances. We lost the fawns in the bad winter. We lose the vast majority of the fawns that are born after the bad winter because of that nutritional suppression that has occurred. So there's basically 2 cohorts. And so if you think, from a hunting perspective, 2 cohorts then that once those cohorts would have been 4 to 6 years of age, there's not going to be a lot of animals in those age ranges because few of them actually made it through. And anyone that made it through, especially after the bad winter, when females are in such poor shape, they're going to carry that nutritional signature of mom barely surviving through that bad winter. And so they're going to be small regardless once they hit that age. Then...
Dude, I'm sorry, man. I got 2 questions.
Okay. I have to try to remember where I was so I don't lose track. But I'll no. Ask your questions.
Down.
Go.
I'm going to write them down. I'm going to write them down.
Okay. Now I feel like it just derailed you.
No. I just got to write them down.
Okay.
1 second. What's I got to write down? Not joking.
Do you want me to keep going and wait till you write them down?
Okay, right now.
The lab.
And
It's almost as compelling as you reading news stories for the first time.
okay, go
But
ahead.
there's a
Go on.
payoff to
Go
this,
on.
Phil.
Yeah.
Dude, listen, it's just that what you're telling me is so interesting to me.
Okay.
But continue on.
All right. So after the bad winters, there's the flush in. Well, actually, let me sidestep a bit. After those 2 bad winters, we had enough data where we can look at what determines whether or not female deer survive bad winters. And there's a few factors that are critical. Yes, the worse the winter is, the lower probability they have to survive the winter. That's intuitive, right? The better food, so like sagebrush growth on their winter range, and in this range, sagebrush is critical. The core of their diet through winter. So more and better sagebrush growth on their winter range helps them survive.
Okay.
Their ability to freely move on their winter ranges and just be able to move and access food on their winter range plays a role.
Is that a function of snow?
Yeah, in part a function of snow. Yep. And then we also see very strong age-dependent relationships. So old females, and so especially in a bad winter, we're going to lose old females, and then some of the very youngest ones. But otherwise, like that sort of prime age from, say, 3 to 7 or so are pretty solid from an age perspective. But the other driving factor and the most profound factor is how fat they were going into that winter.
Okay.
So I think what's important to consider in that, and the reason why it happens this way is if you consider why animals die on a winter, on a bad winter, and you can almost translate this to like any sort of like environmental event that challenges them nutritionally, and that's what a bad winter does. And for an animal to persist through the winter, it just needs to meet its energetic requirements through the course of the winter. And so as you pile up snow, that's going to increase their nutritional deficit. Pile up snow and cold, right? So costs to thermoregulate, maintain body temperature, cost to locomotion, wade through snow and access food. And it's also restricting food. It's reducing their ability to access the food. So all of those things hamper their ability to meet their daily energy requirements.
Yep.
What fat does is it's as if they packed groceries on their back from summer range. And so if that's one of the most profound factors that influences overwinter survival, what it means is that overwinter survival is largely dictated by what they experienced on a completely different range that could be 100 miles away.
Yeah.
And the food that they had access
Months
to
earlier.
there months earlier, and they're bringing that with them to winter range, and that's helping ensure their survival over winter.
Yeah, that's a factor you don't consider
It's,
either.
it's
No.
like how on Alone and some of these survival reality television shows, the contestants try to just pack on weight before they go out there.
Got it.
That's my
They're going to take groceries with
contribution.
them.
Yeah.
Yeah.
You got to bring your reserves.
Mhm.
Yeah.
I ain't ready.
Okay, so I think one significant piece here is after those bad winters, we see the upticks in body fat. That's tied to the added precipitation, but those upticks in body fat stay even after that first year. And it stays for a couple different reasons. One reason is a reduction in density, so fewer mouths on the landscape. And that signature is profound within our data. And many people don't like to hear that, especially when it comes to deer. They may argue like, density doesn't matter. We don't want to hear that. But it's true. The more miles that are on the landscape, the increased competition for food, and that's gonna result in lower body fat.
Who
in those
doesn't
animals.
want to hear that?
It depends. Well, and so it depends upon the context of what it means for who doesn't want to hear that. What the potential implications are of it is that, I guess we'll either get to this now or more so later, but more is not always better. And much of our publics, for example, want more deer. We always want more deer.
Yeah.
But more isn't always better when you consider it from a nutritional perspective of what's happening within a population.
Yeah.
And so, that has been very evident within the Wyoming range with our data there. And so, increased precip, fewer miles on the landscape, lower competition. What's also interesting, and this goes all the way back to our conversation of why we see, for example, even different antler capabilities of size from one place to the next from a nutritional perspective. But what we see after animals have gone through those bad winters, we evaluated what factors influence their gain in fat over the summer. And it's all the things I mentioned. It's habitat, it's precip, it's density of deer on the landscape, it's age, it's whether or not you lactated and recruited young. But the other thing is if you've experienced a bad winter. And so
in the past.
Yeah. And so the animals that live through bad winters, what we see within them is this slight shift in how they allocate their body reserves over time.
You're kidding me.
No, I'm not. I'm not at all. And to the point where
like they learn.
Yeah, and not to like anthropomorphize too much because it's
you took notes. Or
it's
something.
a physiological component. But what it
adapting.
is it's an adaptation associated with this like subtle pre-programming within the animals. That a slight shift, and we call it risk-sensitive reproductive allocation, where the risk they allocate resources to reproduction in a risk-sensitive way, right? And that risk is associated with what they're going to experience thereafter. And again, if they invest too much into reproduction, they're risking their own survival, right? Yeah. Because they need reserves to survive. We have a bad winter that's like life-threatening, and they barely make it. We see that shift in risk-sensitive allocation to the level where there's slight increases in body fat that we see if animals had experienced bad winter in the past, even after we've accounted for all the other factors that are there.
And it's not like, when I said like they learn, it's not that. It's not that they're like, hey man, when the weather gets bad, I got a little move.
Yeah.
Where I go down to old man Lawrence's haystack. Right? It's not that.
No, it's like physiological. It's physiological.
Yeah,
and I think what can also, maybe that sounds crazy. It's not. There's been some very elegant work. And so that work of mine was led by Taylor Lashar, and we drew from some prior work when we decided to investigate that idea from Bård Bartson, who was able to take semi-domesticated reindeer in Norway and ones that were supplementally fed through the winter and ones that were not. And just by way of shifting them, taking the supplementally fed ones and going to a natural pasture, or taking the ones that were from the natural pasture and going to supplemental feeding, animals carried their signature of the range that they were on and how they allocated resources to reproduction. With the exception of those that went from supplemental feeding to the natural pasture, they instantly dropped how they allocated resources to reproduction because it was potentially compromising their ability to maintain themselves, which is the priority. So I liken it to like winter PTSD. These animals had this life-threatening experience, and there's this subtle shift within their pre-programming. And to support that further, and I worked with captive deer for almost a decade. You can have captive white-tailed deer, any captive ungulate for that matter, except for maybe domestic animals, and supplementally feed them the entire year. So they're on the best nutrition all year round. Mm-hmm. And we still see cycles in their diet, how much they eat, in their body fat and body mass through the entire year. When technically, like they're supplementally fed, it could just be constant through the whole year, but it's not. We see these natural rhythms. And so they voluntarily, through the winter, reduce metabolic rate, reduce appetite and how much they're eating to go through those cycles. And so I think maybe it's like, okay, that's cool. So deer slightly reprogram after a bad winter. But I think what it also tells us is that animals are adapted to the local environment within the ranges and the conditions that they experience. To the point where even within an environment like that, when we see this huge shock to the system, we see animals adapting accordingly. And so that should help convince us that when we go from one range to the next, these animals are operating in ways that correspond with that range, so that they're locally adapted, which is the same reason we see antlers the way in which we do, females doing what they do. For example, females in the Wyoming range are not going to gain fat the same way that female deer in southeast Montana are going to. Different range, different environmental conditions. They need different things to be able to persist within that environment. So to go one step further, all these things happening with body fat, the reduction in density within the herd, then we begin to enter into the 22-23 winter, which this is like, 100 plus year winter, like wildest winter that we've seen for decades within that country. We lost 70% of our adult females, all of our radio marked fawns,
all of them,
all gone,
65% of our adult males. So,
Man.
yeah, that
I was-
dropped the population to roughly 11,000 animals through the course of that winter. And I mean, it was like animals were sort of like got so concentrated on the south-facing slope in places where there's like juniper but no food. The hedge line, the browse line in the juniper was like almost as tall as me, where all they would do is just walk these trails around juniper, just eating whatever they could. Sagebrush, any sagebrush that was exposed, like the twigs, everything was eaten to the snow line. I mean, it was a very sad experience in an incredibly devastating winter in that regard for that deer population.
I had it's probably connected to you, but a buddy of mine has a property in Wyoming, and there was some researchers that were doing a little collaring work on his place. I wonder if he might even been talking about your outfit.
Could have been.
It's in Western Wyoming. Anyways, he was telling me how this guy was telling him that during that winter, he's like, it was that there'd be moments.
Yes. Yeah.
There'd be moments when the mortality signals were like bing, 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 bing.
Yep.
So like within this broad time of like really hard, of prolonged period of intense hardship, there'd be like killing moments.
Yes.
Yeah.
Yeah. And so
can you explain that a little bit?
Yeah. So again, this goes back to what we also talked about before, and that animals simply need to meet their daily energy requirements. And fat helps with that. During that winter, and I think this is just a really striking example of this, for females that entered that winter over 15%, that entered winter under 15% body fat, we began losing them on February 15th. Female deer that entered winter over 15% body fat, we did not start losing them till March 15th, a month later.
Wow.
Which, like, if you could just distill a bunch of data in a very simple manner, that's incredibly telling to just be able to say that.
Yeah.
So what that meant is that animals were very much on the nutritional edge. And so they're barely getting by. They're barely meeting their daily energy requirements. And so as we would go through that winter, and that winter was very, very cold as well, when we'd see storms come in or significant drops in temperature for a couple of days, we'd just see spikes in mortality. And that's because what it's done is they're barely meeting their daily energy requirements. We see those drops in temperature. Their energy requirements go up because they're needing to meet basal metabolic demands through the winter in that day, and they just can't do it, and so they die. And so that's where the spikes in mortality came from during that period of time. Now, what I think is also very important and incredibly revealing to the work that we've done there, specifically with regards to bad winters. And if we go back to the 16-17 winter, the 18-19 winter, the recovery in nutritional condition, so body fat that occurred thereafter, and in part, again, because of the signals of the bad winter, but also the reduction in density on the landscape, so fewer mouths to feed. We entered the 22-23 winter at over 12% body fat. So if you remember, do you remember what we entered the 16-17 winter?
Yeah.
7%. So that's a huge difference. Entered 7% during the 16-17 winter, we lost 30% of our females. 22-23 winter, way, way worse than the 16-17 winter. If Taylor ran our survival models for the 22-23 winter based on a 7% body fat level. So had we started at 7% going into the 22-23 winter, we would have lost over 90% of our deer population.
No kidding.
Meaning, we go back to 16-17, 18-19, the reductions in deer density, the recovery in body fat that occurred thereafter. Those winters saved us in the 22-23 winter. Had we come into the 22-23 winter at those lower levels that we were experiencing previously prior to those former bad winters, we probably would have lost essentially everything. Meaning, if we go back to the more is not always better perspective, especially in that, I mean, that's the very clear demonstration of more is not necessarily always better from a nutritional perspective in that way.
Yeah, so if you had more deer going into that winter, it's not the case that more deer would die, but it would be proportional. you'd actually have a higher proportion. If you had more deer on the landscape, you'd have a higher proportion that would die
That's correct.
than if you had fewer deer going into it.
Yeah, that's
Yeah.
exactly right. Yep.
God, it's great, man.
I mean, it's bad, but it's interesting.
When I say great, I don't mean it's great what happened to the deer. I'm
Yeah.
saying it's a great
Oh, yeah. Yeah.
like
With-
input of information. I don't
Yeah.
know, just
Yeah.
like understanding.
Yeah. There's a lot of power in that, just like that scenario and how it played out for us. I mean, the winters basically presented to us a huge experiment or treatment effect, essentially, based on like the severe nutritional limitation and then the massive reduction in density that occurred with that. And fortunately, we were doing the work that we were when we were doing it. Otherwise, we'd still be talking about like how bad winters are, and they are bad. But what does it mean for the population? And even this notion that like, what happens on a winter range, we see it, right? It's very evident to us. These animals die on winter range. But at the same time, one of the major reasons why they're dying is because of what they experienced during the summer and whether or not they brought enough reserves with them from summer range.
And
Have you guys thought about? Sorry, go ahead.
I was going to say, and all that stuff would be invisible unless you had those very individual
That's correct.
data points,
Yep.
right? Like,
Yep.
you're not going to pick that up from, not to poke at the helicopter people, but you're not going to pick that up from an aerial survey. Like, it's a very intimate knowledge of specific animals.
Yeah, and you're gonna see the level of loss.
Right, but you're
Right.
not going to see the underlying.
No, and to be able, for our ability to be able to do that, like we know how old each animal is. We know the fat that they brought with them from summer range. We know where they lived on summer range, and we can connect and build all those pieces together, which also not only allows us to tell those stories, but tell a number of our other stories associated with, how animals learn to migrate. What does it mean for them? What does it mean for their reproductive chronology and their cycle through the year and those sorts of things? Unless we have those repeated samples and the things that we're measuring, we lack the ability to be able to paint that picture. And so that deer that you talked about at the beginning, that really small male, he was born in 2017. So he was born after the 16-17 winter. And yeah, all day long. In fact, I mean, even as for the potential of antler growth that exists within the Wyoming range, I mean, all day long when he was 3 years old, I mean, I would have said, and I think that's kind of what you were referencing too, Steve, I would have called him, he's either a large yearling or a small 2-year-old.
I would have said it in a declarative fashion.
Yeah. And he's three and a half years old.
And I would have also said, I could tell you what he is. Now, my abilities fall apart when they get up to be like 4, 5, 6 years old, but 100% what you're looking at right now.
Yeah, absolutely. Absolutely.
Okay, is it time now?
Yeah, go.
Because this is the benefit of being the host. You get to indulge your questions.
You're
I'm going
driving
to hit
the
you with a
ship.
series of very fast questions because I want more information.
Okay.
A hot tip.
Okay.
You should start a tag service where it's predictive modeling and you sell to people tips. Be like, I would be looking very seriously
Cash in at this
unit
point.
X in 4 years.
I think MeatEater should just hire us, and MeatEater should offer that service.
Yeah.
Okay.
I think. Yeah.
It's called the Monteith Labs or Monteith Tag Service.
Monteith X MeatEater.
Okay, we'll do that.
Okay.
Another quick question.
Yep.
The other day, me and my boy are driving down the road, my older boy, and there's all these sirens and paramedics running around. And we stop well shy, but I take my binoculars and look, and I see something quite startling. There's a wrecked motorcycle. There's 7 firefighters and paramedics working on a man who's like splayed out on the road. And there's a demolished fawn. I don't know, no idea if the guy lived or not. Tried to miss a fawn, hit the fawn. Was a mess on the road. 2 days later, we drove down that road, and there's a doe still standing there, like 100 yards away, but looking agitated. 3 o'clock in the afternoon, she's still on her feet, looking like agitated down in the ditch. Are you ever able to pull out of your data sets what that relationship's like Like if she has a stillborn, does she still hang around? Does she immediately walk away? Do you know what I mean? When she loses a fawn, what is the sort of, there's no way to measure grief.
Yeah.
But like, when does she go like, I guess it's time to move on?
Yeah, interesting question and highly variable from one individual to the next.
Okay.
In most instances with stillborns, though, we can suspect even just via their GPS data around the birth event whether or not they had stillborns because they tend to peace out pretty quickly.
Gotcha. So she knows what happened.
Yeah, that's exactly right.
Yep.
And also many females, like if they lose one of their young later on to whatever reason, rarely do they stick around.
Okay.
They will often leave. However, there are a handful of females that are just their motherly nature, whatever that is, may be there and even defending the carcass still when we arrive. So it's
how long later?
highly typically within 24 hours.
Okay.
By the time when we're working to get in there, but
So
clearly
some would
dead.
leave quicker than that.
Yeah, they're gone by the time we get in there. Yep.
Got it.
Yep. Exactly.
Here's an observation. When you're talking about this thing of like gaming out, how much energy am I going to put into this offspring? It's implied, but just to point to an example of something entirely different. Like think about a Pacific salmon. When they go, they're going.
Yeah.
I mean, do you know what I mean? Like kings can kind of delay. A king salmon can delay. He doesn't have to stay to a set schedule. You know, he can, whatever, his body will make a decision. Like, nope, not going to go. That's why you get huge kings, right? That's why you get, you could get a 70-pound king because for whatever reason, for a number of years, it didn't click and it didn't run. Yeah. But these other salmon that are on a set schedule, it's like, I'm going, buddy. I hope the river's right. I hope the river's right because it's happening.
Yep.
Question. If I took a deer, if I took a buck from Iowa, okay, 180-inch whitetail from Iowa, 200 plus pounds, 180-inch antlers, and I brought him down and put him in Coos deer country in Sonora, does he just die?
Coos deer country in Sonora, he'd probably die.
He just dies.
Yeah.
Because his pattern.
Cows deer. Did you say coos?
Oh,
you led me right into saying
I'll
coos.
fight you over it. Because his groove, his like system just isn't going to translate.
That's right.
Okay.
That's right. Yep.
This one's controversial, so you don't even need to answer.
Ooh. Yeah, that look in your face.
I just wonder about, like, is it even possible? Like, what if you went and looked at human fitness, human physical fitness? Is some of the stuff relevant? People don't like to do that kind of stuff. But
100%. Yeah, I mean, there's a substantial amount, and of course, I don't
like
do
maternal
work in
nutrition.
Oh yeah, huge.
Okay.
There's lots of evidence within human medicine associated with maternal nutrition, maternal
goes
stress.
on and on.
Yes, that translates over generation. Yeah, absolutely.
Got it. That's all my questions. Thank you.
Happens in humans as well. Okay,
that's all my questions.
Maybe a couple other things related to some of these ideas. One of them. Okay, so the other thing that we saw after a couple of those bad winters is on winter range, we tried to keep our same animal distribution over time, roughly. So if we lose animals, we work to go back in and recatch adult females from that same general area.
To keep the same number cooking.
Yep, exactly. Roughly 70 adult females is part of that, is what is with that study. As we were going back to some of the areas where we had routinely caught deer in the past and wanted to replace them, we couldn't find any. Like there was none in there after those 2 bad winters. And so it got us scratching our heads of, okay, well, what does that mean? Did those bad winters just cause animals to like, yeah, I'm not living here anymore and shift out of that country?
Yeah.
When they were pushed by the bad winter because of snow conditions, did they then find a new place that was better and then stay there? Or did they just die and they're not there anymore? So we evaluated that question, and while certainly there are signals, animals can be displaced a bit by a bad winter, which also interesting, though, is a stronger signal of that displacement is if animals had a bad winter the prior year. And so again, it's like this winter PTSD. The shift from where they had lived previously tends to occur after the bad winter as opposed to during the bad winter. So it's like the memory of the bad winter results in a shift from when they would normally winter.
So
Because mule
they
deer
stick it out through the bad
Oh,
winter.
Yeah.
and they're like, but I'm sticking it out. But next year,
I'm going somewhere
Yeah.
else.
I
That's
got you. I
that's exactly right. Because mule deer are incredibly faithful. They're incredibly faithful to their winter range, to their summer range, and to their migratory route. Do the same thing year after year as adults. And so they shift. The winter PTSD shift after the bad winters. But what we learned from that work in particular was that the reason why we ended up with these vacant holes on winter range was because animals died and we lost them.
Okay.
And remember, one of the key factors that influences whether or not they live or die through winter is how fat they were. So what that means is what we observe on a winter range with regards to population distribution, for example, yes, it's influenced by what happens there during winter, but it again is dictated by what happens during summer. So summer nutrition, where animals go and their summer nutrition, plays a huge influence in winter distribution of animals.
So
for a faithful
making
species like that.
They're making a mistake.
What do you mean they're making a mistake?
They're not to hack on them. They're not thinking it through.
They should have. Okay, what's the thinking?
They're
through? Tell me
blaming.
more.
What would you do?
No. I'm not. I'm joking. But I'm not joking.
Yeah.
It's summer range. It's like it has a poor experience on summer range. Goes into a season with low body fat, 6%.
Mhm.
Goes to winter range. Has a terrible winter on winter range.
Mhm.
Its response could possibly be, I need to find a new summer range.
Oh, yeah.
But it's blaming the winter range.
You did this on purpose. Beautiful segue.
Oh.
So they don't find a new summer range. These animals are incredibly faithful to their world as adults. And so they don't go find a new summer range. They just they go back up and do the same thing year after year. So then what that then relates to, I have two things I need to get to. Make sure I get to. One is reproductive chronology. The other is what it means across generation of animals. So what that means in that scenario and how that plays out is, why did that animal end up with that summer range and why did it end up with that migratory route? We know and have known for a bit now that once they have their routes as adults, that it's functionally a trait of the animal that it possesses. Kind of like even saying that this animal is really dark colored. Well, this animal has a 45-mile migration. It summers in Deer Creek and it winters down in Nugget Canyon. Like, it's practically a trait of the animal because that's what it does. So then the question is, how did it get there? Why did that animal end up with that? And so the other thing we've been working on doing is understanding. The only way to get to that is to start from day one from an animal, the day it was born, and then follow it alongside mom, as you were describing early on. And so we've been working to do that, to test this question of ontogeny migration, or like, how do they learn to migrate? Where does it come from? And so, which is also very hard when you have so many bad winters, because it wipes out all your young animals that you've been trying to monitor alongside mom. But we've at least gotten to the point, despite the bad winters, that we've had 16 mother-daughter pairs that we've been able to monitor from daughters growing up to be 3 years of age, to the point where they're reproductively active. Of those 16, 11 of them adopted mom's migratory route. So they basically do the exact same thing that mom does. 5, however, and this sort of gets back to what you were alluding to, 5, however, changed things up and did something differently. What's interesting in that is that there's not even really like a continuous gradient of like, this one definitely did, like right on top of mom's route, and then, it weakens, and then we have some that basically don't adopt mom's route. It's either like you do the vast majority of it or you don't at all.
Got it.
And so there are a handful of young females that disperse and do something differently. They find a different migratory route. And so there are a number of them that do things differently, but not as adults. Adults is pretty fixed. The young animals, a few do it. But the ones that do change, it seems like whatever they do during their yearling year, so when they turn 1 year of age, is what they then end up doing for the rest of their lives. Like, that's what establishes it. What's also really interesting, and is not what I would have expected, which Again, our sample size is only 16. We have more to go here to be able to get there to do this. But the ones that adopted a different migratory route, much to my surprise, they largely clung to where they lived on summer range, but then migrated to a different winter range. And I would have thought it would have been the opposite, especially with regards to what you just said. We'll go somewhere else to summer.
Yep.
The majority of them are still residing close to their natal range where they were born, but they adopt a different migratory route and go to a different winter range, which I'm not entirely sure what to make of that yet, but that's what we've seen.
What if they? So you're saying that at sort of the yearling stage, that's the pattern that they adopt for the rest of their lives. Are
Yes.
they? Is there any correlation to like if the mother dies before they turn one? You know, like
Yep.
are more of those deer likely to be these sort of pathfinders, or what's the relationship there?
Very good question, which we're only looking at 16 at the moment. But in looking at those 16, there seems to be no relationship to whether or not mom dies or mom lives. That seems to not play a role, at least as of yet. But to then take that to the level of like why we see deer where we do, how they get there, all of these pieces which determines why animals live where they do and the success that they have. For deer anyway, it all starts such early in life. It's a cross-generational process, clearly, that we need to be able to document from them. And one, maintaining migration is clearly something that translates across generation as young learn from mom. But two, and so that means we're also conserving memory on a landscape.
Yep.
But two, also, I think the few animals that did something different maybe is like a glimmer of hope that, you know, when things are lost, so if we lose certain migratory routes, how do we get them back is the question. Because if everybody's faithful to what they know, then nobody's going to go back there. And I firmly believe with what we've been able to learn about mule deer over the past 15 or so years, that something is hampering us or has hampered us from the past to the present is when we've lost certain animals across the landscape that migrated into certain places before. I mean, there's, many people can say, man, there used to be deer all over this ridgeline and I just don't see deer here anymore.
Yep.
And they may reference a number of reasons why they think that is. They may reference it as an elk hole now, it's full of elk or whatever the case may be. But the reason why they potentially don't come back is because the only way to get that backfilled is for animals to be pioneers and venture out into new range, which adults tend not to do. And so we're relying on that small proportion of few yearlings to potentially regain that space. And if we lose, this is that, vacant space, Randall, we've, talked about a bunch as well. If we lose occupancy of those places on the landscape over time for whatever reason, we lose memory to those places. What that's doing is it's functionally reducing the carrying capacity of the range. If you don't have animals using it, it technically doesn't matter.
Yep.
It may be viable habitat that's there, but for it to matter to the population, somebody needs to be using it and integrating that food into the population.
That's so interesting because you look at places like that and you're like, what is it about it that's not? Why don't they like it?
That's right.
And
And that's what we think.
Yeah.
Why aren't they going here? Well, nobody knows to go there, and so how do you get them? How do you get them back in there?
In salmon, there's a sorry, Randall.
No, go ahead.
In salmon, some percentage of a run, I always say they screw up, but some percentage of a run doesn't go back to the natal stream.
Mm-hmm.
They screw up,
End up somewhere else.
but think about the implications of it.
Yeah.
Because river systems change.
That's right.
There could be a river that doesn't have suitable spawning gravel.
Mm-hmm.
And then a flood, whatever, landslides, I don't know, something. And all of a sudden, boom, it's great.
Yep.
Some fish is going to some number are going to screw up and go up that thing. And then it could be
something
a gold mine.
Yep. It's a
So
portfolio.
this place is sweet.
Portfolio effect.
And all of a sudden you create a new,
Yep.
right? And think about I think I always, when I think about that too, is as climate changes, there's a lot of salmon rivers that would be great salmon rivers, but they're too far north. It's too cold, right? So because you have that dispersal mechanism, things could just suddenly become kind of right.
That's right.
And some fish is going to take a left when he should have taken a right and wind up finding a new.
Exactly.
I mean, it takes two, but you follow me.
Yeah.
It's just
Yeah, absolutely.
I got a technical question for you. If I see let's say a fella sees a nice buck on the last day of season, say it's November, a fella sees a nice buck on November 24th. So no one got him. He could die from other stuff. But the next year on November 24th, in your mind, how far is that deer from where he was the year before, based on your research?
All depends.
It does.
Yeah.
But he's already an adult. He's already set in his ways.
So we're working on understanding those aspects of males as well. Male dispersal from their natal range, how faithful they are to their seasonal ranges as well. And I mean, in general, as you noted, they're living within their range, right? And so I think the certainly not that far from there. He lived up in that country, right? The only wild card within that is during a hunting season, as males get potentially pushed around. He may have been in a non-normal place than what he often is, the 1 year that he's seen versus the next year. But certainly,
I could have seen him at a moment when he was in a spot he don't want to be.
Yeah. That's exactly right. But otherwise, he lives in that country. So they're there. Yeah.
When you're talking about restoring a lost migration corridor on this habitat, like because it would be a yearling. A yearling with some wanderlust that takes off down a new ridge or whatever else. There aren't going to be any other deer that then convert to that range. It's all going to come from that deer's offspring, correct?
Most likely.
Yeah. So it's a long.
It's a cross-generational process.
You're talking about multiple generations before you have like a herd of deer using that.
That's right. Yeah. Which reinforces the importance of maintaining what you have, because you are maintaining and protecting memory on the landscape. And if once we lose it, especially for such a faithful animal like a deer, we don't necessarily get it back just like that. Versus elk, where they'll just go anywhere. They'll take advantage of whatever happens to be there. But for deer, their memory is like their fence around their world of what they do. And I think another thing that I think this is just super interesting, and I think speaks to the level of intimacy between female deer and their environment, is that if you consider mule deer who all share a common winter range, okay? Mm-hmm. Some migrate 10 miles, some migrate 120 miles. The one that migrates 120 miles is typically often going to be going to higher elevation, potentially traversing a lot of country, dealing with snow conditions in spring, stuff like that. In an ideal world, and for mule deer, they want to go back and give birth to the range they typically give birth in. We've literally had female deer give birth in the exact same bed site 1 year after the next. They're very faithful to their birth sites. So then the question is, well, what does that mean for them to time birth to coincide with when food is available on their summer range, and for their ability to get to their summer range to give birth? And so we looked at that in as we talked earlier, we not only see animals on the day they're born, but we also see them in utero. So when we recatch females in March, we see the fetuses in utero, and we measure their eye diameter, which gives us an indication of how far along in gestation they are. So we've been able to put those pieces together to look at what factors influence eye diameter in March. So that gestational progression, what determines where they are in March, and then what does that mean thereafter? Because one of the strongest signals that determines when animals give birth is how far along they were in gestation in March. So we can use fetal eye diameter. In fact, we use it to help guide our planning in the spring when we're going to catch mule deer fawns or bighorn sheep lambs, the anticipation of who's going to give birth when. We use fetal eye diameter that we measured in March.
But that's like fine tuning within a pretty narrow window, though.
To some degree. For sheep, it can be pretty broad, but for deer, yes, it's fine tuning within a narrow window. That said, we then looked at, so since fetal eye diameter plays such a major role in when they give birth, we looked at factors that influence fetal eye diameter. And I think one of the most fascinating aspects that influence fetal eye diameter is how far they migrate. So animals that migrate further have smaller eye diameter in March than those that migrate short distances. if that may. So the ones that migrate short
Yeah.
distances are further along in gestation in March, which means they're going to give birth sooner.
Because they're closer to the
That's
range.
right. That's right. And green up is going to happen faster on that range than the range that's
man.
way up in the mountains. So, the influence is roughly for every 10 miles migrated based on our models. For every 10 miles migrated, that's 1 day behind in gestation. So for an animal that basically hardly migrates to an animal that migrates 100 miles, it can be 10 days expected differences based on their fetal eye diameter from when they're going to give birth. That animal that migrates 100 miles is going to give birth 10 days later. Now, to take that one step further, and this happened, I forget the exact year, it was 2020. On June 2nd, I was with one of my team members, Randall Jacobek, and we went into Deer 96, up into where she gave birth that morning, collared her twin fawns. And then we went on and did other work the rest of the day. And then we got a birth notification from a vaginal implant transmitter later that evening. We were about 2 hours before dark, and we're looking at it. And the animal that we just got a birth notification from was about 300 yards down from where we had just been that morning, collaring twin fawns from 96. And I'm like, man, wouldn't it be cool to hustle in there to see if we can collar, like, two animals give birth on the same day that live in the same place? So we hustled in there and then collared the single fawn from that female on that same day. So, which makes sense, right? Animals living in this same area, giving birth on the same day. So 96 was the one that was up the ridge, and then it was MFO that was down below the ridge. Now, we had 3 years earlier, in spring of 2017, we had collared MFO who had just been born to 96 in that same place on June 3rd. So
I got lost.
Mom and grandma are giving
mom and
birth.
daughter. So MFO, who we went in that afternoon to collar her fawns,
I got that.
was 96's daughter from 3 years prior.
Oh, really?
Really. 96's daughter from 3 years prior, giving birth on the exact same day, on June 2nd. And
300 yards down the hill.
Yeah, exactly. Same place, same birth date. And also, she had been born 1 day difference in the calendar 3 years prior. So, and while that's like seemingly an anecdote, we've seen it and had it happen multiple times within these family groups, which indicates to us that not only is space on the landscape, migratory routes on the landscape inherited across generational time, but even their reproductive synchrony, the reproductive chronology, is inherited across generational time. Like, that's how in sync they are with their environment. And I think what's also equally fascinating, if you consider how the mule deer rut happens, not all of it, but a lot of it happens down a winter range, right? They migrate down to winter range. And so on winter range, we have all these animals with all these different migratory tactics that are showing up on winter range, and they're all rutting in this same place. And then, but what it means is what's happening is Gladys over here, who migrates 10 miles, she comes into estrus on November 20th. But then Jennifer over here, who migrates 100 miles, she doesn't come into estrus until 10 days later on December 1st.
Okay.
Right? Even though they're on the same winter range in the same place, their estrus cycle is tied to actually where they go during the summer, and it has virtually nothing to do with where they're at on that day on winter range.
Damn.
Yeah.
Do you see a lot of, besides seeing a lot of stuff that dudes say, do you see things that state game agencies are doing, or the way they're thinking about these issues and management? Do you see things where you're like, that just doesn't make any sense?
You're wanting me to like step on a landmine? Yeah.
Yes, I would like that.
How long does it take for the management to catch up with the science?
And are you in good communication with everybody?
Well, so there's one challenge with all of this, right? No matter what, we're all people, and we've all done things a number of different ways, and we've just accepted them to be true over time without necessarily pausing and saying, wait, why do I think that? Where did that come from? What evidence support it? And is it
why
just...
Why do I think that screaming at my kids all the time
yeah.
is helping?
That's exactly right.
It didn't help with me.
I mean, So a fascinating example of that, well, like when I grew up in northeastern South Dakota, and we hunted deer every year, whitetail deer every year, just locally there, to feed our family. And my dad and my grandpa always used to say, like, man, the deer are fat this year. I guess we're going to have a bad winter. Like, they would say that over and over again. And I mean, I remember as a kid thinking, wait, like, how do they know it's going to be a bad winter?
Mm-hmm.
How do they know to prepare for a bad winter? And the thing is, we know now, like, they don't. Like, that is technically not the case. Although, if you consider it relative to local adaptation, and in the example that we just talked about with this pre-programming and allocation of reserves after experiencing a bad winter, there's simultaneously some truth to that.
Yeah.
Because it's tied to what animals have experienced, maybe less so of knowing they're going to experience something, but it's associated with what's happened in the past. And so I think there's just many things that we operate within that we generally don't question. This is just how we do things. And so that's where we go. That's where we go. And so there's always some challenges in rethinking where we have been and being willing to reconsider new information. I think that's hard. That's hard for anybody.
You're being diplomatic.
Probably. And the thing,
do you sometimes look at management strategies and management practices and think to yourself, that just doesn't make any sense?
Well, sure.
Okay.
Sure. But I can also, like, there's also, and I mean, with full respect for my colleagues with management agencies, like, we're also stuck in this difficult position where, well, it's not necessarily a difficult position, but they manage wildlife resources in trust, right? Fundamental aspect of the North American model. Yeah. We're all owners of it. But it's managing it as a trust on behalf of the public. Yep. And so what that means is they don't get to just sit in a room and just say, well, here's what we're going to do because biologically this is the best thing to do. They also have to consider what the public wants in that regard, social pressures. And so it can be an incredibly difficult balance at times. And so oftentimes I view it as, yes, we need to, as we learn things, what can that mean for us in updating how we think about various management practices, for sure. That's like, maybe that's like, baseline level of what does it mean for us as we consider management practices. But then we don't, to then take that the next step, we don't necessarily get the opportunity to just say, okay, we're going to change this. We need to be able to bring that information to the public, which is also what's so incredibly valuable, like of your platform here and ability to be able to speak about these things is, I think what's critical is that we can bring this information to the public because there are a lot of things that we're just stuck on that have happened for a really, really long time that, oh, this is the solution. This is what we need to do, but it's not as simple as that. So being able to communicate it in meaningful ways that connects with people and maybe change their perspective on things is sort of like ground zero for helping institute management change.
Would you ever have the time and appetite to take your data sets from your bucks and take a look at lunar phase stuff? Does this interest you at all?
Well, so I have thought about that.
With movement.
Yeah.
Movement.
No, we certainly could. We absolutely could. And you're talking from like a rut perspective because there's so much focus on, or are you talking like during the hunting season? Just
the idea, it would be, I mean, you could go down a million rabbit holes, but just generally this.
Yep.
That deer are moving at different times, moving in different places, different feeding patterns according to moon phase.
We absolutely could.
And you could take, because you have so much data, someone could go in and look at what you got and map it out to 28-day lunar cycles and say like, lo and behold, they do seem to behave differently according to the lunar, or you'd be like, we can't find it. That would be very helpful to me.
Would it?
Yes. Okay. Thank you for doing that. Do we need to endow with our T-shirt proceeds? Should we like endow a?
You absolutely should.
Like endow a researcher.
The Center for Lunar Studies. The Rinella Center for Lunar.
I'm just thinking an intern crunching some numbers.
I already talked to someone the other day about that. We might have him on the show. Totally debunks that.
He debunked. Well, maybe he can. Can you?
Does he have the data?
Do you lend your data sets out? Is that a thing?
In collaboration, yeah. So it all depends, but in collaboration, yeah.
Here's my next question for you.
Okay.
What what things are you that you haven't been able to do besides lunar phase work? Like, what do you want to be doing? Jimmy, like, what do you want to be doing next? Like, what things do you look at and you're like, I'm inspired by it, and I think I can see a way that we might find some answers.
Like with this deer work in particular,
just any kind of your work.
Yeah,
do you know what I mean? Like, you got to have 50 ideas, right? But then in the end, you can only do 1 or 2 at a time, or whatever. I don't know what the numbers are.
Yeah,
but.
For sure. Well, I mean, one of the things which we talked about a little bit is we really need to be able to evaluate the rose petal hypothesis, which I think we've talked maybe a little bit about. So the rose petal hypothesis ties to deer in particular, but how they occupy space on a landscape. And the reference to a rose is that you have a matriarchal female that forms maybe the central petal on the rose, and then you have her daughters that set up shop around her, and then her granddaughters. And so what you end up with is this matrilineal line of related females that occupy space on a landscape. They've evaluated this in white-tailed deer. It's where the idea came from initially. So for white-tailed deer, it's been used to implement management practices to reduce agricultural depredation-related issues. So where deer are getting into crops and that sort of thing. And the idea is that just removing a handful of deer from the area won't alleviate the problem, because you still have other females that are living there, and then their daughters and granddaughters are just going to repopulate it. So the notion is, if you want no deer there, you need to wipe out the entire rows, and then you'll create vacant space, and there won't be any deer there, and your problem will go away. Well, so as I've thought about migration, migration is central to our ability to maintain large, robust populations. And then, as adult deer are incredibly faithful to their environment, then where does it come from anyway? And so we talked about ontology migration, but then taking that one step further, what does that mean for how females occupy space on a landscape, in particular their natal range? Like, do they, even though they're migratory, do they similarly adopt space from mom on their summer range? So do we end up with these then matrilineal lines of occupied space on a summer range? And that's what determines why we have animals where we do. And that, again, which we kind of alluded to a bit, but that's central to our ability to maintain an abundance of deer. Because if we lose roses, we create vacant space, and they're not there anymore. And we need a firm answer of that to understand what that means across generational time. To both be able to look forward to what it can mean for management conservation now, but also I think what's equally as of value is to be able to look backwards in time to what it means for us in the past, from what we've seen, how the landscape has changed, and what we see today. And relevant to even just the Wyoming range, when we lose 70% of our deer population, we inevitably lost roses on the landscape.
Yeah.
I mean, we had family groups of our radio marked deer that were just completely wiped out. So at that level of loss, it inevitably happened. So what does that mean for that vacant space over time? And if you
when you're somewhere, when you're glassing and you hunt the same place over a few years, and you're there's always a little pocket of activity.
Yep.
In whatever little spot.
Yep.
You could just gone. Your
Why
pocket of activity.
aren't they there anymore? What happened? Did they get pushed out of there? Well, no, not necessarily. They probably just all died. And so,
and no one's backfilled.
That's right. And so, what that could mean, we've had a number of which there's a lot of challenges that mule deer face. But if you think this applies to basically any population of ungulate, if animals are not using space, then a population may grow back up, but reach a new abundance where they don't grow anymore. Because if they're not using all that other forage and space on the landscape, that's not functionally part of their carrying capacity. It's like having a pasture, running cattle on a pasture, and you have 1,000-acre pasture, and you split it down the middle with a fence, and you run cattle on the southern half of it. Are you going to run the number of cattle that you have for the 1,000-acre pasture, or are you going to run the number of cattle that you have for the 500 acres that they have access to? And you're going to run it on the 500 acres, not the 1,000. And so when it comes to, even as we think about, nutrition density within any population, and I hear this a lot, man, how could nutrition be limiting on summer range? Look at these mountains. There's food everywhere. There's no way that could matter. Again, you have to remember what it means for the animals themselves and the spaces that they live and occupy on that landscape, because they just don't go willy-nilly wander around unless you're an elk, and just access all of those foods.
So you're talking about, basically habitat loss. You were losing mule deer habitat, even though the habitat looks the same.
Yeah, that's exactly right. Yeah, it's a good way of putting it. Yeah.
Yeah, it's so interesting.
Yeah.
When you think about like spots, you're like, why are they not here?
Yeah.
Yeah. And when are they going to come back?
Man,
Yeah.
you know where, maybe you're already doing work here. You know where I feel like there's so much personal bias applied to any conversation around ungulate density and predation,
Mm-hmm.
right?
Mhm.
You got people who the first thing they want to do,
Mm-hmm.
anytime there's no deer around, they want to tell you about the predators.
Yep.
You got people who basically want to tell you that predators eat grass.
Mhm.
Makes no difference, right? You
Mhm.
got these two camps.
Yep.
They're generally not talking about what they regard to be the truth. They're talking about what they wish was the truth, or how they've been brought up or trained, right? These two wildly different perspectives.
Yes.
Do you do you consider, are there ways to maybe freshen up that conversation about what is going on?
Yeah.
What do coyote numbers mean for deer populations over time? What do coyote numbers mean for distribution?
Yeah.
Right? Do you weigh in on this?
100%.
Yeah.
Yeah. So I actually sent some of my initial predator related work as it translates to ungulate population was actually some of the work I did on mule deer in the Sierra Nevada in California.
Okay.
And
I read that work.
Did you?
Yeah. I didn't know it was you.
Oh, yeah.
Really?
I did a whole bunch of work on nutrition predation on deer in the Eastern Sierra.
Oh, you know what? You're right, because you're even not I mean, you're right. But I think I saw you, now that you're saying this, I saw you cited. Your work is cited in the California's bear management proposal. Your Sierra Nevada work is cited there.
Yeah.
I just read that and it left my mind.
Yeah.
Okay. I saw your name there.
Yeah. So, and then of course we've done a number of good bit of predation related work in Wyoming as well. To sort of like look at a big picture relative to the two camps that you reference,
Which camp is right?
Well, here's the thing. The problem is neither camp is right.
I had a suspicion.
Yeah, and anybody, the problem is the moment anybody wants to say predators don't matter because all mortality is compensatory, or predators matter basically if a canine is on the landscape and it's killing a deer. If that canine wasn't there, we'd have the deer back.
Mm-hmm.
Both of those camps are wrong. The fact that there's even camps is wrong, and it's wrong in part because of the way in which we think about it. And part of the challenge has been like, how do we understand what predation means within populations? And where we have to go back to regardless first is what makes a population, and what makes a population is everything we've talked about, and it's food and access to the landscape. And so the bottom line is, unless animals have access to the food and their basic requirements, food, water, cover, then it doesn't matter. And so, for example, if we're in a place where animals are at the capacity of their landscape, no matter what, basically any ungulate population is going to attempt to grow more young each year than they can actually sustain within the population typically. And so what that means is a number need to die, and hence compensatory. And if we're at that point, one dies and it alleviates some level of competition for the others that remain. And so we end up with this feedback. So that's real. And also we can have this situation where predators can play a role, as in we have the capacity to grow more animals based on the food that is here, but predators are keeping it from growing.
Mm-hmm.
So we first have to consider food, and we can quibble and argue, oh, this level of coyote population, this level of lion population, whatever the case may be. At the end of the day, you can't interpret anything from that. It actually doesn't mean anything, because even for those predators, like they may have alternative prey that's available to them. Where it matters, how we understand how predators affect a prey population, is actually to understand the prey population and the nutrition and capacity they have to grow before we can actually interpret it, what the predators matter or mean at all. And the other reason why I say both camps are wrong, or that the very notion, like the moment you hear somebody toss something into the camp, you already know they're wrong. And it's because we can be in a situation in one single population, and during one period of time, predators are limiting growth. And during another period of time, they don't matter at all because they're so nutritionally limited that they make no difference. And so you have yes here and you have no over here.
Yeah, I got you.
And then imagine the whole gradient in between. And I've worked in 2 systems now as an example in the Sierras, in the Eastern Sierra, where predation mattered for one migratory segment, didn't matter at all for the other. And then also looking at it from a time period of there was a window of time where predation mattered, and then a window of time where it didn't matter at all. And we've seen the same thing in Wyoming as well. Same picture within the Wyoming range. Prior to the bad winters, predators really didn't matter because we didn't have the nutritional capacity to grow more deer anyway. We were there. So losing some to predators really was going to be a wash and didn't matter. Now that we've dropped to the level that we have now, and our females are fat, robust, we have the capacity to grow. Now we're in a different situation where predators can have a limiting factor and reduce the ability for the population to grow. But then still at the end of the day, well, what does that mean for us? Should we control predators? Should we have controlled predators over here? Should we not? Like, it's the sort of like, it all depends. What are the objectives? Just because you remove predators from a system doesn't mean you're going to get more deer back. Yeah.
Dude, you should be the only guest we ever have on.
You'd get so bored.
No. It'd be a weekly show where I ask you questions.
I like it. I like it.
Because we're never going to get through it all. Like, we got to wrap up.
Yeah.
Randall got to do this whole stupid thing we're doing.
This whole stupid thing you're doing.
It's the audiobook, folks.
We haven't even talked about Kevin's fascinating other interests: taxidermist, hunter.
Maybe we should just.
There are layers to this
I know,
onion.
I know.
Let's not wait 5-7 years again. I don't know whenever it was we did the last
We got to
one.
schedule the next round because we got to wrap up. But dude, it's really like you guys are doing super cool work.
Thanks.
I wasn't trying to
Fortunate
hack
do it.
on fish and game agencies, man. I was more just trying to express this. I was trying to express this like I just hope there's not a lot of bottlenecks and inefficiencies in like being able to take the research you're doing and being able to go and say like, I can't tell you anything, but it really looks like this is going on. Are we considering this?
Yeah.
Do you know what I mean? Is the flow?
No, I get that.
Is the flow good?
Yeah.
And I'm only saying that because like, you know, I've spent my whole life talking about wildlife, right? Thinking about wildlife, talking about wildlife. I hang out with people who are obsessed with wildlife, and we routinely traffic in stuff that just isn't backed up.
Yeah.
And we say it like fact.
Absolutely.
And the guys that are doing management are my guys, they're peers.
Mm-hmm.
It's like people are operating under assumptions that like aren't as accurate, you know, and sort of looking at like looking at low deer numbers and be like, well, the reason it's that way is because of whatever.
Yeah.
And then you can look at me, man, dude, it's just a different. There's more to what's going on. It's a longer story.
Yep.
It's not like you can't just, everything isn't just looking at what just happened.
Correct. Absolutely.
You know, you got to dig back oftentimes. You got to dig back right now. And so in trying to correct a situation, you might be correcting the wrong inputs.
Yes. Oh, absolutely.
Right?
Yep, for sure. And I think the other side of that as well is, you know, a number of things that we talked about, some of the things we can't necessarily change. We can't necessarily change the weather and those sorts of things, but which I think can become a bit dissatisfying sometimes when like precip or snowpack or those sorts of things play such a driving role. We can manage density and other things like that to help moderate those things. But I also think what's really important is our ability to simply manage our expectations as well. What does it mean for us? Which is kind of dissatisfying, right? When you can't say, well, do this because I want this. Well, maybe we can't get that, but here's the reasons why, and we need you to understand that so we can all be at the same table with the same information, be like, okay, here's what we're wrestling with. What is this going to mean for us going forward? Mm-hmm. With whatever the situation may be, from how we use habitat to our presence on the landscape, to how we manage hunting seasons. Yeah.
Love it.
Mm-hmm.
Man, you got to come back on.
Okay. Happily.
No, you're not too terribly far away.
No.
Last time we went to you. Remember that?
You did. You did. We got to hang out for a bit.
Well,
Yeah. Yeah. It was great.
we got to go, though. Me and Randall got our
Just do
thing
a
we're
pod
doing.
series
Me and Randall's
with
thing
him.
is actually kind of interesting. I don't want to talk bad about it. You know?
I just,
It's very similar in a way.
Yeah,
We're
I
trying
feel
to
like-
find out what happened. What did happen? to
I
all
know.
the
I feel like
buffalo?
you were very into it. I feel like you were very into that project up until this morning, and now the it's dimmed.
You know,
It's dimmed. It's,
we're doing very similar work.
Yeah.
We are.
I like it.
We're looking at like what did happen to all the buffalo
Nice.
and why, and what little micro things might have been different that would have led to a different outcome. We toy with all this.
Mm-hmm.
We toy with all this,
Good.
and
But we don't have the data that you have.
well, it's just different kind of work.
Yeah.
Yeah.
And we dispel things.
So yeah, that's important too.
People are like, well, what happened was this. And I'm like, yeah, kind of. But also this,
Nice.
you know.
I look forward to that. Bison are fascinating.
Yeah, I think you'll dig it. It's got all the normal gross stuff that we like to put in there too.
Of course. I would anticipate nothing
Yeah,
less.
we like it to be that you get kind of grossed out, but also you learn some stuff.
You have to have that flair. It wouldn't come from you guys.
Yeah, you got to
right?
have that like cadence of you being like, oh,
Yeah.
then you're like, oh,
Phil, can we clip that for some sound effects?
Yeah, that'll be in the new
We
album.
can just splice that in.
yeah, it's, oh, and then it's oh, yeah. Back and forth, all just. Ooh. All right, thank you for coming on the Monteith Shop, University of Wyoming. Send your resumes. You looking for resumes right now?
Oh man.
You drowning in resumes.
Yeah.
Don't send your resume.
Always looking for supporters if anybody's interested.
If you're looking to support something great, and I think it was demonstrated here today, if you're looking to support, if you love wildlife, if you love the West, if you love wildlife, if you love these like majestic landscapes, and you really want to put your money, your conservation dollars to knowledge, this is a great place to put them. If you want to drive knowledge, it's not lobbying, which is important. It's not like on the ground habitat improvement, rolling up old fences, getting rid of junipers, which is important. It's not that. If you want to contribute to acquisition of knowledge that can then be extended out into management, I say the Monteith Lab is money well spent.
Shop.
What was that?
Shop.
Oh, what did I just call it?
Lab.
Well, that's what they ought to call it.
Yeah.
If you think about it.
I think that's where we started.
Oh my god.
The more I think about it.
It doesn't bode well for our recording session later.
The Monteith Shop, damn it. Thank you, Kevin.
My pleasure. Thank you for having me.